Maya, when we talk about running AI models locally on your device, most people think about a laptop summarizing a PDF or a phone cropping a photo. But what if I told you that you can now buy a $4,000 box that sits quietly in your closet and runs a massive data center grade model completely offline?
Laughs. Wait, a literal data center in your closet? Like, next to my winter coats?
Chuckles. Exactly. And here's the wild part. If the model gets too big, you don't have to throw the box away. You can just buy a second one, snap them together like Lego, and double your brain power.
It's like building Voltron right on your desk. Today, we are leaving the smartphones behind and looking at the high-end frontier of edge AI, the personal AI supercomputers, the smart home brains, and how these local giants are quietly rewiring our relationship with the cloud. Disclaimer first.
First, a quick and honest word. Everything you're about to hear is really just the two of us thinking out loud. Personal market commentary, made for learning and for fun. It isn't investment advice, and it isn't a recommendation.
And when we talk about a specific company, it's only ever to make a bigger idea click, never a nudge to buy or to sell. So take it as a starting point for your own curiosity. Do your own research and make the call that's right for you.
Welcome back to The Working Thesis. I'm Theo.
And I'm Maya. First, our routine and necessary housekeeping. This show is for education and entertainment only, not investment advice. We mention companies like NVIDIA, AMD, Apple, and various hardware OEMs as public examples of industry trends, never as recommendations to buy or sell anything. No price targets, no trade setups. Always verify everything live and do your own research.
To understand this high-end world, we have to look at the actual hardware taxonomy, because tech media tends to conflate everything into AI hardware. In reality, there are 4 distinct tiers of local AI running today.
Tier A is the NPU AI laptops and desktops we covered in Episode 2. Your standard Copilot Plus machines, great for light assistance and offline transcription. Tier B is the gaming and creator PCs powered by dedicated desktop GPUs like the RTX series. That's actually where the vast majority of local AI hobbyists play today.
And then there is the brand new category that launched over the last year, Tier C, the personal AI supercomputers. These are specialized, high-memory desk-side towers designed specifically to run large, 70 billion to over 400 billion parameter models completely locally. And finally, Tier D, the ultra-premium, multi-GPU professional workstations. Today, we are focusing squarely on Tier C because it is the most strategically disruptive.
And the flagship player in this new Tier C category is NVIDIA's DGX Spark, which shipped in late 2025. It is powered by the Grace-Blackwell GB10 SoC. It packs a 20-core ARM CPU and a massive Blackwell GPU, delivering a staggering 1 plop of AI performance.
But the key stat that matters for running large local models is the memory. It carries 128 gigabytes of unified LPDDR5x RAM.
And unified memory is the magic sauce here. In a traditional PC, your GPU has its own small, fast memory, and your CPU has its own larger, slower memory. If your model is bigger than your GPU memory, you are in trouble. But with a unified memory architecture, the entire 128 gigabytes is shared. The chip can load a massive 70 billion parameter model directly into memory and run it at lightning-fast speed, completely on your desk, for around $4,000.
But the most fascinating part of the DGX Spark is how it handles expansion. It brings NVIDIA's data center playbook directly to your home. It features a built-in ConnectX 7 high-speed networking port.
And that is the Lego block part. If you want to run an even bigger model, say a massive 405 billion parameter Llama model, you don't have to buy a massive server rack. You just buy a second DGX Spark, link them together with a high-speed cable, and the 2 boxes cluster together to act as a single, giant, unified computer.
It is a brilliant scale-out architecture, and strategically, it does something very clever. It keeps developers locked into NVIDIA's CUDA software ecosystem and high-speed networking. It is the exact same moat NVIDIA has in the cloud, shrunk down to the size of a shoebox.
But AMD is playing a completely different strategic hand. Their contender in this space is powered by the Ryzen AI Max Plus Strix Halo APU, which you can find in mini PCs like GM Tech or HP Workstations for around $2,000.
The difference is that AMD is a scale-up, standalone design. It supports up to 128 gigabytes of memory, and you can allocate nearly 96 gigabytes of that directly to the GPU. It is incredibly fast, simple, and costs almost half the price of the DGX Spark.
But you cannot link two Strix Halo boxes together. It is a single, capped node. So the choice is explicit. NVIDIA offers an extensible, network-clustered playground that locks you into their CUDA moat. AMD and Apple's Mac Studio offer standalone simplicity and spectacular performance per dollar, but capped at 1 unit. Both paths, however, drive massive unified memory content. Every single one of these boxes is a massive sink for memory chips.
Now, what happens when we move this local supercomputing brain away from developers and use it to run an entire household? This brings us to the Home AI Hub.
Today, if you want a smart home, you are almost entirely dependent on the cloud. When you ask your smart assistant to turn off the lights, that request travels to a cloud server, gets processed, and travels back. If your internet connection goes down, your smart home turns into a very dumb brick.
Chuckles. Oh, we've all been there. Staring at a smart light bulb in the dark, wondering why turning off a lamp requires a multi-million-dollar server farm in Virginia.
Exactly. But with on-device AI, the local PC or Tier C box becomes the private, always-on brain of the household. It can run a local model via open-source tools like Ollama completely offline to coordinate your entire home by voice with zero lag and absolute privacy.
And the plumbing that makes this local AI hub possible actually exists today. It is called Matter and Thread. Matter is the new IP-based interoperability standard backed by Apple, Google, Amazon, and Samsung.
And Thread is the low-power mesh networking protocol that connects the individual devices. The beauty of Matter and Thread is that they support local control APIs natively. They don't require a cloud detour to talk to each other.
So the setup is ready. You can run Home Assistant on a local box, connect it to your local Matter devices, and control your entire home using a private, local voice satellite. No data is sent to the cloud, no subscription fees, and it works perfectly even if your physical internet cable is cut. It is privacy-first home automation.
And this local brain makes smart home hardware far more interesting. Take security cameras, for example. Today, a typical smart camera is just a dumb lens that uploads raw video to the cloud, charging you a monthly subscription to run basic object detection.
With local vision AI running on your home hub, the camera doesn't need a subscription. The local hub can parse the video feed privately, recognize who is at the door, and flag a package delivery entirely on your own hardware.
Exactly. It shifts the value from cloud subscriptions back to local hardware. It makes devices like local cameras, voice satellites, motion sensors, and even emerging smart energy gear and household robots far more capable and interesting. But there is a massive catch. The device manufacturers must support local APIs. If a camera is locked into a proprietary, cloud-only subscription model, it breaks the local hub entirely.
And that is the real tension of this home hub story. It is privacy and local control versus plug-and-play convenience.
Right. Setting up a local Home Assistant hub with Ollama is still very much enthusiast territory today. It requires some technical chops. The vast majority of mass-market consumers are going to default to the convenient cloud-tied offerings like Amazon's Alexa Plus, Google Gemini for Home, or Apple's rumored Home Hub.
Convenience wins 99% of the time in the mass market.
Absolutely. But even if the mainstream home hub stays cloud-tied, the technology represents a real, viable prosumer alternative. And as those local models get smaller and smarter, the plug-and-play mass-market hubs themselves will quietly migrate more and more of their basic routing onto the local hardware inside the house, just to save the tech giants their massive cloud compute server bills.
So, step back and look at the structural picture we are building across this series. From laptops, to phones, to local smart home hubs, to personal AI desktops.
Every single branch of this edge AI tree is incredibly hungry for one specific physical component: memory. A standard laptop used to ship with 8 gigabytes of RAM. Now, Copilot Plus PCs require 16, and developers are buying 32 to 64 to run models locally.
And these Tier C personal supercomputers are shipping with 128 to up to 784 gigabytes of unified memory per unit. Whichever silicon or software standard wins the edge, the total bit demand for memory chips is exploding. It is a giant structural demand wave that is colliding with an already tight global supply.
It's an elegant, multi-billion-dollar trap. The hardware is expanding, the local brains are getting incredibly smart, and the money is flowing up the chain.
And that wraps our third episode of AI Comes Home. We covered the supercomputer in your closet and the local smart home hub. Next week is the big finale of this series. We are going to follow the memory directly to the quiet, structural winners of this entire device boom. We'll look at the massive global memory shortage happening right now, why standard DRAM contract prices have doubled, how Apple is scrambling to secure supply, and who actually owns the bottleneck under the entire edge.
We don't predict. We test the thesis as the evidence lands. We'd love to hear your thoughts in the comments. Would you put an AI supercomputer in your closet? Thanks for spending part of your day with us. Until next time, take care and keep following the money. That's a wrap for today. Thanks for thinking it through with us. We're just testing our theses out loud, one day at a time.
Catch you on the next one. Stay curious and tell us where we're wrong.